In this lesson, we're going to learn about the properties of matter. There are two types of properties of matter. We have physical or chemical properties. A physical property can be observed or measured without changing the chemical makeup of the substance. In other words, you could measure it or see that property without changing what the substance is. For example, you could measure the mass of a piece of wood, for example, and that wouldn't change the fact that it's a piece of wood. Or you could measure the size, the volume of a piece of wood. A chemical property does change the makeup of the substance when you try to observe or measure that property. For example, we could test a piece of wood for being flammable. In order to do that, you have to catch it on fire. And when a piece of wood burns, it turns from a piece of wood to a piece of char or ash, which changes what the substance is. Some examples of physical properties are the state of matter, solid, liquid, or gas, its density, its luster, how shiny it is, its malleability, which is how well you can hammer it into thin sheets, its odor, its texture, its color, the melting point, boiling point, things like that. You usually can use the five senses to measure physical properties. You could either see that gold is shiny, or hear that metal rings well, or you could feel that a piece of rubber is bendable, things like that. For the states of matter, we've learned about this before, but we're going to learn about this on the particle level. So for a solid, that means the substance has not yet reached its melting point. If it's water, you could think of it being frozen. All of those atoms or molecules or particles, whatever you want to call them, that are in the substance, they're very close together and they're in fixed positions. They don't get to move around a lot. So like this block here, all these little particles, they're stuck where they're at. They might vibrate a little bit back and forth, but they don't actually move. And because of that, because those particles are stuck in that particular position, it has a definite shape and a definite volume. That means that you can measure the size, you can measure the shape, you know exactly what it is. Liquids, on the other hand, they're very similar. Their particles are still very close together, but they can move past each other. That means that the substance has reached its melting point, but it hasn't started boiling yet. It hasn't started evaporating. Those atoms are very close together, but they can move around. You can measure the volume. That's why we have graduated cylinders and beakers and things like that. But it doesn't have a defined shape. It takes whatever shape of the container it's in. In gases, these particles are very far apart. This is past the melting and boiling points. It's already evaporated. Now they've got so much energy, they're just bouncing around all over the place, and they're far apart from each other. And they're moving very quickly. You can't really measure the volume of a gas because there's so much space between the particles. There's just a lot of empty space there. And it always takes the shape of its container. Like if you put gas in a balloon, it takes the shape of the balloon. Or the air, which is a gas that's in your classroom, it's in the shape of the classroom. So to sum all of that up, solids have a defined shape and a definable volume. You can see what that volume is. Liquids, you can figure out the volume, but you can't figure out the shape. It takes the shape of whatever container it's in. And gases, you can't find either the shape or the volume because they're very subject to change. Density is one of those physical properties I mentioned, and it's a very important one. So we're going to learn how to figure out what density is. Density is the amount of mass per a unit of volume. Most of the time we use grams per centimeter cubed or grams per milliliter, which is the same thing. Density is not dependent on how much you have, unlike mass or volume. So mass, it depends. If you have a larger block of something, it's going to weigh more. Or if you have a smaller block of something, it's going to have less volume to it. But since density is a ratio of the mass to the volume, or it's mass divided by volume, that ratio should always be the same for that particular substance, no matter how much of it you have. Some other physical properties, which I've touched on a little bit before, is malleability, the ability to be hammered into thin sheets like aluminum. You can make an aluminum foil hat like Weird Al over here. Ductility, which is how well you can string a piece of metal into thin wire. Luster is how shiny it is. Texture is it rough or smooth? Color. Melting point, at what temperature does it turn from a solid to a liquid? Boiling point, at what temperature does it turn from a liquid to a gas? Odor, does it stink? Let me move on to chemical properties, which we're not going to go too deeply into right now. We should have a general idea. Flammability is, will it catch fire? And keep in mind, to test that, you have to catch it on fire, which changes the substance. Reactivity, does it react with other chemicals? Will there be a chemical reaction that happens? And you have to undergo a chemical reaction to see that, and it changes what that substance is. pH is something you can measure. Is it an acid or a base? The heat of combustion, which is how much energy is released when it burns. Toxicity is how damaging it can be to a living organism. Radioactivity, is it stable? Is it going to decay quickly and throw out radioactive particles? And things like that.